Hello, dear students. Today we are going to solve October-November 2012 1-2 paper. It's MCQ paper, and let's start. On your screen, you can see question number 1. The level of water in a melting cylinder is 75 centimeter cube. A stone of volume 20 centimeter cube is lowered into the water. What is the new reading of the water level? You see, we have a melting cylinder. It is filled with water, and the level of the water is 75 centimeter cube. And what you did put a stone into the melting cylinder. The volume of the stone is 20 centimeter cube, so the level of the water will go up. The new reading on the melting cylinder will be showing the sum of the volume of the water and the volume of the stone. So it will be 75 centimeter cube plus 20 centimeter cube, and the answer will be 95 centimeter cube. So for question number 1, the choice is D. Question number 1, the choice is D. I hope you have understood. Okay, dear students, we are moving to question number 2, a little bit tricky question. The diagram shows 3 forces acting on a block. On your diagram, you can see there are 2 forces acting towards the left side, 3 Newton and 2 Newton, and 1 force is acting towards the right side, which is 11 Newton. Which additional force will produce a resultant force of 3 Newton to the left? So you see, we want a resultant of 3 Newton. We want a resultant of 3 Newton towards left. We want a resultant of 3 Newton to the left. So if I want this as a resultant, I need to balance this. This I want as a resultant, I need to balance this with this. So what extra force I need to apply to the left side? This is 2 Newton force, this is 11 Newton force. To balance this 11 Newton force in the right direction, I need to put 9 Newton force to the left. If I will put another 9 Newton force to the left, so this 2 and 9 will make 11. It will be balanced with this 11, and this 3 Newton will be a resultant towards the left. So I need to put a 9 Newton force to the left side. So the choice for question number 2 is C. Okay, let's reduce the size a little bit. He says, a table tennis ball is released from the top of an evacuated tube. The tube has no air, it's total vacuum in it. Which graph shows how the speed of the ball changes with time as it falls to the bottom of the tube? So you see, when a body falls in a vacuum, its acceleration remains constant. So if I will draw a speed time graph, the graph will be a inclined straight line. So choice A is showing a graph which is a speed time graph, and it's an inclined straight line. So choice is A, because when a ball falls in a vacuum tube, the acceleration remains constant, which means the slope of the speed time graph will be constant. So a straight line graph will represent this motion. So the choice is A. Question number 3, the choice is A. On your screen, we have question number 4. The speed time graph for a car is shown. It's a speed time graph. On the x-axis, time is represented. On the y-axis, speed is represented. What is the acceleration of the car at 30 seconds? So this is 30 seconds. Let me increase its size so I can show you how this is done. Okay. Now you see from 30 seconds go straight to the graph. So this is the point. So it's a speed time graph. You know, if you want to find out the acceleration on this point, so you will draw a tangent. on the speed time graph, and the slope of that tangent will represent the acceleration. So if I will draw a tangent at that point, it will be a horizontal line. On this point where the time is 30 seconds on the speed time graph, if I will draw a tangent, that tangent will be a horizontal line. And you know the slope of the horizontal line is 0. So the acceleration here will be 0. So the acceleration of the ball here will be 0. So the choice is A. I hope you understand this question. Okay, on your screen we have now question number 5 is showing on your screen. The diagram shows a firework rocket. As the rocket flies through the air, 3 forces act on it. These forces are weight, thrust, and air resistance. You know, here this R is representing weight. This S, which will be opposing the motion of the firework rocket, that is air resistance. And Q is the thrust produced by the firework rocket. So S, the thrust is represented with Q, the air resistance is represented with S, and the weight is represented with R. So for question number 5, D will be the choice. For question number 5, D is the choice. Let's move to the next question. Let's increase the size also. Okay, on your screen you can see question number 6. An object has a mass of 15 kg. It is pushed horizontally by a force of 40 Newton. The frictional force is 10 Newton. What is the acceleration of the object? You know, here the applied force is given 40 Newton. The frictional force is given 10 Newton. We can find the resultant force. Resultant force is applied force minus frictional force. So it will be 40 Newton minus 10 Newton, and that will be 30 Newton. So once you have the resultant force, then you can apply Newton's second law of motion. F equals ma. The resultant force is F, m is the mass of the object, and a is the acceleration which is produced. So F is equals to ma. F is 30 Newton, m is 15, and if you want to find out a will be 30 divided by 15, and the answer will be 2 meter per second square. 2 meter per second square is C choice. For question number 6, the choice is C. If you want to see the calculation, I can show you. On your screen, you can see question number 6, and its calculation is shown. First, I calculated the resultant force. Then I applied the formula F is equals to ma. From there, I put the value of the resultant force. I put the value of the mass. And then I calculated the value of A, which came out to be 2 meter per second square. So the choice is C. Okay, question number 7 is on your screen. Let's reduce the size. Okay. He says an object Y is in a fixed position on a rod. A weight X is moved and the position of a pivot is adjusted until the rod balances on the pivot as shown. The experiment is repeated in a region where the gravitational field strength is lower. What is done to keep the rod balanced? You see, you have to do nothing, because the value of the G which will change here, the same value of the G will be changed here. So the effect of the G here and the effect of the G here, because it's acting on both the sides, the G value is affecting the anti-clockwise moment, G value is also affecting the clockwise moment, and it is acting on both the clockwise and anti-clockwise side. It's affecting the clockwise moment, and it is also affecting the anti-clockwise moment. So because it's affecting both the sides, so it is not under, it can be ignored. The fact of the G can be ignored. So if you move it to another location where the G value is less, you don't have to do anything. So pivot, you don't have to move. X, you don't have to move. No movement, no movement. So for question number 7, D is the answer. I hope you understood this question. Okay, on your screen, we have question number 8. 4 solid uniform cones have equal weight. They are placed on a bench as shown in the scale diagram. Which cone is most suitable? Most stable. For a body to be stable, its base area should be wide and its center of mass should be at a lower height. So C looks the best because its base area is wider, larger base area, and its center of mass is lower. So C is the choice. Question number 8, C is the choice. Okay, on your screen, can you see we have question number 9 is on your screen. The diagram shows the length of a spring changes when a load of 10 Newton is hung on it. The 10 Newton load is replaced by a 20 Newton load. What is the new length of the spring? Here the unstretched length, which is represented with L naught, is given 5 centimeter. When you put a weight of 10 Newton, the new length is 8 centimeter. So we can calculate the extension. When a load of 10 Newton is hung, the extension is equals to L minus L naught. L is 8 centimeter minus L naught is 5 centimeter. So the extension is 3 centimeter. The extension and the load, they are directly proportional to each other. So when the load is 10 Newton, the extension is 3 centimeter. When when the load is 20 Newton, what will be the extension? I have done this on a paper. Let me show you that. Okay. So on your screen, you can see when the load is 10 Newton, the extension is 8 minus 5, which is 3 centimeter. When the load is 20 Newton, what will be extension? So 10 divided by 20 equals to 3 divided by x. So do cross multiply, get the value of the x, that will be 6 centimeter. But the question is, what will be the new length? The new length will be L naught plus extension. L naught, unstretched length, is 5 plus extension is 6. So the answer is 11 centimeter. It means when you will hang a 20 Newton load, the length of the spring will be 11 centimeter. So for question number 9, the choice is B. I hope that this question is clear to you. Okay, so now we are moving to next question. Question number 10. Question number 10 right now is on your screen. The mass and the volume of a bar made from metal X are measured. The masses and the volumes of 4 other bars are measured. Which bar is made from a metal with a density that is double that of X? So suppose that the mass of the X is M and the volume of the bar X is V. So its density is suppose D, and the D will be equals to M by V. So we are looking for another metal whose density is double that of the density of X. So different conditions are given. Okay, so let me show you my work. Okay, so on your screen, question number 10, you see, suppose for X the density is M by V and we are calling it D. In the A option, he told us about a metal whose mass is double. So its mass is 2M and its volume is half the volume of X. So its volume is V by 2. So when I do this calculation, the answer is 4m by V, so it's 4d. So its density is 4 times the density of X. Let's do the calculation for the metal B. Its mass is half the mass of X. Its volume is same as the volume of X. So put these values in the formula for the density, m by 2 divided by V. So its density 1 by 2 m by V, so 1 by 2d. So its density is half the density of the X. Let's do the calculation for C. Its mass is same as the mass of the X. Its volume is double the volume of X. So when I will do the calculation for its density, it will be 1 by 2 m by V. It will be 1 by 2. So its density is half the density of X. Now we will do for the D part, or the D option. The mass is same and the volume is half that of X. So it will be 2m by V equals to 2d. So its density is double the density of X. And this was what we were looking for. So the question number 10D is the option. It's a little bit tricky question. I hope you have understood it. Question number 11 is on your screen. 4 solid blocks with flat surfaces are placed on some soft plasticine. In the position shown, which block sinks the deepest into the plasticine? The block which will be creating the greatest pressure on the plasticine will sink the deepest. And how do we know that it is creating the greatest pressure? If the area of the contact with the plasticine is smallest and the weight is largest, or the mass is largest, it will have the largest pressure on the plasticine and it will sink into the plasticine the deepest. So the block whose mass is 1 kg has the largest mass, and its contact area, when the contact area with the plasticine is 10 centimeters square, that is the most suitable for this purpose. So the answer is B, because its mass is largest, which is 1 kg, and its contact area is smallest, that is 10 centimeters square. So it will create the largest pressure and it will sink deepest into the plasticine. So B is the option. Question number 11. B is the option. I hope you understand. Okay, on your screen we have question number 12. The end of a bicycle pump is sealed. The temperature of the air does not change as the piston is pushed in. The final volume of the trapped air is 1 by 4 of the original volume. How does the pressure of the trapped air change? You know, if we are talking about the pressure of gas and the temperature is kept constant, and you know the pressure and the volume, they are inversely proportional to each other. If the pressure and the volume of the gas are changing and the temperature is kept constant, the pressure and the volume of the gas are inversely proportional to each other. So whatever will happen with the volume, opposite will happen with the pressure. If you will reduce the volume to 1/4, the pressure will increase 4 times. The pressure will become 4 times the previous pressure. I have done is working mathematically. Let me show you that. Okay, so question number 12, D part, is on your screen. P1 V1 equals to P2 V2. When the temperature is constant, this equation is used. Let's the pressure is P, the volume is V. Pressure 2 is question, so I kept this as P2. The volume 2 is 1/4 of the previous volume, so the V2 is V by 4. So do the cross multiplication. VV is cancelled. So P2 is 4P. So the pressure 2 will be 4 times the original pressure, the previous pressure. So the option is D. For question number 12, the option is D. It increases to 4 times the original value of the pressure. I hope you have understood this question. Okay, now students, we are moving to question number 13. He says hydroelectric, tidal, and fossil fuel power stations generate electrical energy. Do these use renewable sources of energy? Hydroelectric is renewable energy source. Tidal is renewable energy source. Fossil fuel is a non-renewable energy source. For question number 13, the option is D. For question number 13, the option is D. I hope you have understood. On your screen, we are showing question number 14. An object of mass 5 kg is carried a distance of 4 meters across a room at a constant height above the floor. What is the work done on the object? You see here, you are carrying an object at a constant height and you are moving 4 meters. So the work done will be 0 because the the body is not moving in the direction of the force which you apply. So the work done will be 0. One force which from the mass we can calculate is the force you apply to keep the object at a certain height. That force will be equal to its weight. But the body is not moving in the direction of that force. The body is moving horizontally. So the force which we know, which is equals to the weight, the body has moved perpendicular to that force. If the body moves perpendicular to the applied force, the work done is 0. So for question number 14, the answer is A. Question number 14, the answer is A. Okay, students, we are moving to the next question. On your screen, you can see question number 15. It says a gas in a container of fixed volume is heated. What happens to the molecules of the gas? You know, we have a guy, he's talking about a gas and its volume is fixed. The volume is not changing. So, and it is heated. So what will happen? The average kinetic energy of that gas will increase. It means that the gas molecules will be moving faster. So the choice is C, they move faster. The best answer is C. Question number 15, C is the option. On your screen, we have question number 16. In hot weather, people use electric fans to keep cool. Why do the fans make them feel cool? You know, when you keep a fan and what happens due to the hot weather, you are sweating, and due to the fan, the rate of evaporation of the sweating from your skin increases due to the fan. So that keep your body cool. So the answer is C. They increase the rate of evaporation from the skin. So for question number 16, the answer is C. Okay, dear students, we are moving to question number 17. It's on your screen. 4 metal cans are identical except for the color and the texture of their outer surfaces. 100 centimeter cube of water at 70 degrees centigrade is poured into each can. Which cools the most rapidly? You know, the most rapidly that can will cool. Whose surface is the best emitter of the infrared radiation? And the best infrared radiation will be that surface which is black and which is rough. Black and rough surface will be the best emitter of infrared radiation, so it will cool most rapidly. So the choice is A. For question number 17, the choice is A. Question number 18 is on your screen. A liquid in glass thermometer consists of a bulb containing a liquid which expands into a very thin capillary tube. The liquid in the thermometer is replaced by the same volume of a different liquid that expands more for the same temperature rise. The new thermometer will be, you see, when you replace the previous liquid with another liquid who expands for more for the same rise in the temperature, now the new thermometer will be, it will be more sensitive and it will have less range. Because a smaller change in temperature, it will reach to the end of the thermometer because it's expanding more. So the thermometer will be more sensitive, no doubt, but it will be less, its range will be less. So B is the option, greater sensitivity but a smaller range. Question number 18, B is the choice. Okay, on your screen we have a question. An ice cube at a temperature of 0 degrees centigrade has a mass of 10 grams. The specific latent heat of fusion of the water is 3 expo 5 joules per kg. How much heat energy is needed to convert the ice cube into 10 grams of water at 0 degrees centigrade? One thing you should notice is that the specific latent heat of fusion is given, but its units are 3 expo 5 joules per kg. For mass, it used a unit of kg. The mass which he gave us of the water is 10 grams. It is not in kg. So the units are not consistent with each other. So that mass 10 grams should be converted into kg. How you do that? You divide the 10 gram with 1000 and it will be converted into kg. You can apply the formula heat is equals to ml, where m stands for the mass and L stands for the latent heat. I have done this work. On your screen you can see heat is equal to ml. The mass was 10. I divided it with 1000. Multiply with 3 expo 5. The answer is 3000 joules. A very simple question. Only trick was that you have to do a conversion from gram into kg. So the option is 19. Question number 19. The option is B. For question number 19, the option is B. This option, 3000 joules. Okay. So on your screen, question number 20. A strip is made from two metals joined together. The diagram shows the strip at room temperature and after it has been cooled. So you see when it has been cooled, it bended upward. On the upper portion, the metal was brass, and on below, the metal was inward. And when you cooled it, it bended upward. We call it bimetallic strips. When you cooled it, it bended upward. Why it bended upward? Because the brass has contracted more as compared to inward. That's why it bended upward. The brass is contracting more and the inward is contracting less on cooling. That's why it has bended upward. Suppose if the inward was contracting more and the brass was contracting less, on cooling it would have bended downward. But now, the given situation, it has bended upward on cooling, which shows that the brass is contracting more than inward. So A is the choice for question number 20. A is the choice. Okay, on your screen, let me reduce the size a little bit. Yeah. In our ripple tank, a vibrator produces circular wavefronts which hit the flat surface. The reflected wavefronts are also part of circles, which where is the center of these circles? You know, here the reflection will take place. And you remember the reflection in the mirror? If the center of the incident wavefronts was D, if the center of the incident wavefronts was D, then the center of the reflected wavefronts will be, it will appear to be on A. It's same as the image of when you stand in front of a plane mirror. Your image is exactly the same distance into the mirror, behind the mirror, as you are in front of the mirror. So D, its image will be exactly at A. So the wavefronts which are reflected, it will appear, it will be seen that it's the center of the from where they are coming out will be at A. So the choice is A. I hope it's clear to you. Okay, question number 22 is on your screen, and an object is placed in front of a plane mirror. The image produced is, whenever you stand in front of a plane mirror, the image formed in the plane mirror has some properties. We can name some properties. For example, in the plane mirror, the image formed is always virtual. The distance of the image from the mirror and the distance of the object from the mirror is same. The size of the image and the size of the object is same. The image is always upright. So if you look at the choices given, D is the right choice. The image will be virtual and the same size as the object. So for question number 22, the choice is D. I hope it is clear. Okay, question number 25, 23 is on your screen. A ray of red light enters a semicircular glass block normal to the curved surface. Which diagram shows the partial reflection and refraction of the ray? For getting to the right option in this question, dear students, you need a scale and a pencil and follow my instruction. You know this point on your screen, this point, this flat surface of the semicircular glass block. On this face of the glass, draw a normal with the pencil and scale. Kindly draw a normal. On this point, figure B, draw a normal. On this figure, draw a normal. On figure D, with the help of the pencil and a scale, draw a normal. When you will draw a normal here, then you will observe for reflection in the figure D, the angle of incidence and the angle of reflection, they are equal to each other. So it's good. And then you will observe when the light came out from the glass into the air, when it came out of an optically dense medium into an optically rare medium, it was supposed to bend away from the normal, and in the figure D, it has. So the right figure is D. You see, I have only considered explained to you the right figure, which was D. When you will draw actually the normal, as I have told you, you will observe that in the figure A, For reflection, the angle of incidence and angle of reflection are not same, so it's rejected. In figure B, when you will draw a normal, you will observe that the angle of incidence and angle of reflection for the reflection, they are not equal to each other. That's why the figure B is rejected. When you will draw a normal in figure C, you will observe that the angle of incidence and the angle of reflection, for the reflection purpose, they are equal to each other. So for reflection, it is good. But you will observe when the light emerged out of the glass, it emerged out of a dense medium into a rare medium. It was supposed to bend away from the normal, but it bended towards the normal. That's why the option C is also rejected. So the only correct option is D. I hope you are following my instructions and you are able to understand this question. It's a little bit tricky question. Okay, so we are moving to next question, question number 24. Question number 24 on your screen. A lens is used to produce a magnified image as shown in the scale diagram. What is the linear magnification of the object? We want to calculate the linear magnification. You know, the linear magnification formula is height of the image divided by height of the object. So take a scale, because if you have a hard copy in front of you, take a scale and measure the length of the image. Measure the length of the image. Then measure the length of the object. Then measure the length of the object. Divide the length of the image or height of the image with the height of the object or length of the object. You will get the linear magnification. Another way of getting the linear magnification is, we have a formula. Linear magnification is distance of the image from the optical center of the lens divided by distance of the object from the optical center of the lens. So take the scale and from the optical center measure what is the distance of the object. I'm saying from the optical center measure what is the distance of the image. Measure this horizontal distance. And also measure the distance of the object from the optical center. Measure this horizontal distance. Divide the distance of the image with the distance of the object and you will get the linear magnification. So I have done this and the answer is B. Question number 24, the answer is B, the answer is 3. I hope you have understood it. On your screen, now we have question number 25. Which statement about red light and blue light is correct? You remember that code word which we normally use in our videos. We say Roy G. Biv. Roy G. Biv. Roy G. Biv stands for red. We say red, orange, yellow, green. Roy G. B-I-V. We say Roy, R-O-Y-G, Biv, B-I-V, Biv, Roy G. Biv. Red, orange, yellow, green, blue, indigo, violet. As you move down in this list, red, orange, yellow, green, blue, indigo, violet, Roy G. Biv. What happens as you go down, the wavelength decreases. As you go down, the frequency increases. So he's comparing red and the blue. The red has higher wavelength and the red has shorter or less frequency. Red has longer wavelength than blue light. B is the right option. For question number 25, B is the right option. I hope you are able to understand. Okay, so we are moving to question number 26. A magnet is placed close to an iron bar. So you see, this is a magnet, and close to it we have an iron bar. And you know the iron bar is a magnetic material. So due to magnetic induction, poles will be generated on this iron bar. So this left end of the iron bar, X, is near the north. So here a south pole will be induced, and here a north pole will be induced. So on X we will have a south, and on Y we will have a north, magnetic induction. So, and X will be south and Y will be north. So C is the choice. Question number 26, C is the choice. On your screen, you can see question number 26. A small uncharged metal sphere hangs from an insulating thread. A negatively charged rod moves close to the sphere. Here we have insulating thread and a metal sphere. It's made of metal. And here is a negatively charged rod. When you bring it near, on this end, positive charge will appear, and on the right side of this metal sphere, negative charge will appear. And due to this positive and this negative, it will be attracted towards this. So if you imagine that scenario in your mind, you will see A should be the best answer. Which diagram shows the charges on the sphere and its final position? So A is the right option. It looks to me A should be the right option. Think carefully. I think A is the option for question number 27. I hope it's clear. Okay, sir, we are moving to next question. Question number 28 is on your screen. A metal wire has a length L and cross-sectional area A. What is the resistance proportional to? You must have heard this, that the resistance of a conductor is directly proportional to L and it is inversely proportional to area. So directly proportional to L and inversely proportional to area. So R is proportional to L by A. R is proportional to L by A. So the choice is C. Dear students, the choice is C, L by A. Question number 28, C is the choice. I hope you understand. Okay, on your screen we have question number 29. A student joins three 6-ohm resistors as shown in the diagram. You know, three 6-ohm resistors, they are connected parallel to each other. What is the total resistance between the point X and point Y? You know, if you have three resistors connected in parallel to each other, we can find their equivalent resistance. On your screen, I have shown that. For parallel combination, the equivalent resistance is 1 by R equals to 1 by R1 plus 1 by R2 plus 1 by R3. 1 by R equals to 1 by 6 plus 1 by 6, 1 plus 1 by 6. So it will be 3 by 6. So cross multiply, get the value for R, that will be 2 ohm. So the equivalent resistance of the whole circuit will be 2 ohm. So the choice for question number 29 is B. Question number 29, the choice is B, 2 ohm. I hope you understand. A very simple numerical on resistors connected in parallel. Okay, we are moving to next question. P, Q, and R are electric symbols. What do these symbols represent? You know, this symbol R is a resistor, fixed resistor. So R is a resistor. So here. Q is the symbol for fuse. So here. And this is a symbol for a relay coil. Okay, so B is the choice. Question number 30, B is the choice. Okay, sir, on your screen we have question number 31. A lamp is rated at 60 watt on a 240 volt supply. What is the current in the lamp when used normally? You know, power is equals to IV. The power is given, V is given, I is question. So I will be equals to P divided by V. 60 watt divided by 240 volt. And you can do this calculation. I have also done this calculation. Let me show you on your screen. Question number 31 is showing P is equals to IV. I put the value of the power and the voltage. I value 60 divided by 240. The answer is 0.25 amp. And the option is A. For question number 31, option is a very straightforward, simple question on the power formula. Power is equals to IV. Option is A, sir. Question number 31. Simple. I hope you have understood. Okay, so question number 32 is on your screen. The cost of electricity is 16 cents per kilowatt hour. What is the cost of using a 3 kilowatt heater for 4 hours? Whenever you calculate the electric energy for the purpose of calculating its cost, the, the formula is electric energy equals to power into time. And the cost is power multiplied time multiplied the price of 1 unit of electricity. In this formula, the power must be in kilowatts and the time should be in hours. So then just put the values and you will get the answer. I have done this calculation. Let me show you. Question number 32 is on your screen. Can you see that? So cost is power multiplied time multiplied price. The power must be in kilowatts. The time must be in hours. Just multiply 3 kilowatt multiply 4 hour multiply 16. So this option is given in the answer. So 4 into 3 into 16. So C is the answer. You see, C is the correct answer. Okay, so we are moving to next question. Question number 33 is on your screen. Two parallel wires carry current in opposite directions. Three plotting compasses are placed in the position shown. The current in both wires are reversed. How many compass needles change direction? Ignore the effect of Earth's magnetic field. Question number 33. So you see the current in the right side wire is going downward. So the magnetic field around it will be clockwise. So you can see the magnetic compass needles is showing clockwise. And the wire on the left side, its current is going upward. So use the right hand rule. And its magnetic field will be anti-clockwise. So the magnetic compasses put around it, they show the magnetic field is anti-clockwise. So he says, I change the direction of the current. So now when you will change the direction of the current, so now the right wire will have a current going in the upward direction. So apply the formula, apply that right hand rule. My thumb is in the direction of the current. For the right wire, we are doing this. So my curves, the curves of my finger are telling me that the direction of the magnetic field should be anti-clockwise. So the compass needles will change. Okay. The left wire current will be going downward. So apply the right hand rule. My thumb is in the direction of the current. The curves of my finger are telling me the direction of the magnetic field should be clockwise. So the magnetic compasses put there, their direction will change. So all the three magnetic compasses, their direction will change. So for question number 33, D is the option. It's a little complicated thing, but I hope you have understood. Okay, question number 34 is on your screen. Which single coil motor has the largest turning effect? That motor will have the largest turning effect. Who has the largest number of turns? Who has the largest amount of current? And who has an iron core in it? So it looks D is the answer for question number 34, which has a current of 10 ampere. It has 200 turns of coil and it has an iron core in it. So it will have the largest turning effect. So question number 34, D is the option. Okay, on your screen, question number 35, a magnet is moved towards a coil of insulated wire. A voltmeter connected across the coil shows a positive reading. What produces a higher reading on the voltmeter? You know, if you are moving a magnet and near a magnet we have a coil, so due to the motion of that magnet, EMF is induced in the coil. So how you can increase the reading of the EMF produced in the coil. You use a stronger magnet, you move the magnet faster, or you increase the number of turns in the coil. So there are three things: use a stronger magnet, move the magnet faster, or use a coil with the more number of turns in it. So for question number 35, C is the option, moving the magnet towards the coil at a faster speed. The EMF induced will be larger. There will be a larger reading shown on the voltmeter. Question number 35, C is the option. Okay, sir, on your screen we have question number 36. The diagram shows the output of an AC generator as displayed on a cathode ray oscilloscope. The horizontal scale is 5 milliseconds per centimeter. So on horizontal, this one square is representing 5 milliseconds. His question is, what is the time for one complete rotation of the coil of the generator? So for one complete wave, how much is the time? So count for one complete wave horizontally, how many squares are used? So this wave started from here, it finishes here, completes here. So 1, 2, 3, 4. So there are 4 squares used. Each square represents 5 milliseconds. So there are 4 squares used, so the time period is 20 milliseconds. For question number 36, 20 milliseconds is the time period to complete one wave or one rotation of the generator. So the choice is C. Question number 36, the choice is C. Okay, on your screen we have a question. The trace of a waveform is seen on the screen of a cathode ray oscilloscope. So the vertical gain is set on 1 and the time base is set on 2. Okay, the question is, let me use the size. Which statement about controls is correct? The amplitude of the trace is changed by adjusting the time base. That's wrong. Time base has nothing to do with the amplitude of the wave. The amplitude of the trace is changed by adjusting the vertical gain. Yes. If you change the vertical gain, the amplitude which is shown on the CRO screen will change. So B is the choice. The whole trace is moved to the right by adjusting the time base. No. The whole trace is moved upward by adjusting the vertical gain. No. So B is the right choice, sir. B is the right choice. I hope you understand. B is the right choice for question number 37. Okay, we are moving to the next question. Let's increase the size. It says, on your screen, we have question number 38. How many protons are in the nucleus of an atom of radium? Radium is 88226. So its proton number is 88. How many protons are there in the nucleus? 88 is the proton number. This number here in the subscript, this is its atomic number. Atomic number is equal to the proton numbers in its nucleus. So this atomic number, 88, is its proton number. So number of protons in its nucleus are 88. For question number 38, the option is A. Okay, let me reduce the size. Okay. The diagram shows the radioactive emissions that passes through a piece of plastic and a piece of metal of the same thickness. So in the first figure, you can see the alpha, they cannot pass through the plastic. The beta, they can pass through the plastic. And the gamma, they are also able to pass through they can penetrate the plastic. So beta and gamma, they can penetrate the plastic. Then he put a metal of the same thickness. Alpha cannot pass, beta cannot pass, but the gamma still can penetrate through the metal. Which type of radioactive emission can distinguish between the plastic and the metal? So if you have a beta radiation, and it will be able to distinguish between plastic and metal. Because if the beta passes through the material, it's plastic. And if the beta is stored by the material, it is metal. So beta only. C is the choice for question number 39. Okay, sir, question number 40 is on your screen. the background count rate in a laboratory is 10 counts per minute. The measured count rate from a radioactive source is 410 counts per minute, which includes the background. The half-life of the source is 5 days. What is the measured count rate after 50 days? So see, the background count rate is 10. And when we measured the radioactive source, its count rate was 410 and the background is included. So first of all, take out the background. So from 410 counts per minute minus 10 counts per minute, the actual count rate of the source is 400. The half-life is 5 days, and he's asking how much his count rate will be after 15 days. So in 15 days, how many half-lives will be there? 15 days divided by 5. So there will be 3 half-lives. So if you have a count rate of 400, you half it will become 200. Again half it, it will become 100. Again half it, it will become 50. So after 3 half-lives, the count rate will become 50. Now what will be the reading? You add again the background into it. So 50 plus 10, the answer will be 60 counts per minute. Let me show you my working also. It may be helpful to you. You can see on, let me increase the size so that, yeah, on your screen, you can see here. Here you can see question number 40. So first of all, for 410 minus 10, I've taken out the background. So the pure count rate of the sample is 400. And the half-life is 5 days. And he's asking how much will be the count rate after 15 days. So there are 3 half-lives, 15 divided by 5, 3. So 400, after 1 half-life, the rate will be 200. After another half-life, the rate will become 100. Another half-life will pass, and the rate will become 50. So 3 half-life have passed. The count rate has dropped from 400 to 50. So what will be the reading on the instrument? 50 plus the background, 60 will be the answer. So the choice is C. So the choice is C, 60 counts per minute. So my dear students, today's paper is over. It was November 2012. 1-2 paper, an MCQ paper, and I hope that I am a little bit help to you. Keep doing the hard work, and God willing, your answering skills will improve. Thank you very much for today's watching my video. Thank you very much, everybody.